tangent graph. All right, so y equals the tangent of x. All right, we're going to kind of cheat here a little bit. Get your calculators out. And I'm going to mark along the x-axis the same thing that we did for the sine and cosine. So I'm going to go over here to pi over 2, and then pi, and 3 pi over 2, and 2 pi. And I can go in the other direction as well. I'm just going to stop there for the negative pi over 2. All right, now, just like I say, we'll just kind of maybe cheat here a little bit. By the way, don't forget that on Thursday will be that first unit circle quiz, so get yourself familiar with that unit circle. Plug in your calculator tangent of 0. Let's go through some values. Tangent of 0. What is it? 0. Now remember, y over x, that would be 0 over 1, so that would be equal to 0. Plug in the tangent of pi over 2. What'd you get? What would you get?
It says error domain.
Error domain, what'd you do wrong?
Put in pi over 2.
Let's
see.
Anybody else get an error domain? Anybody not get an error domain? Good for you. I was trying to trick you, to be quite honest. Is it possible to not get an error domain on that? Yeah.
Nope, because I've seen the graph.
You've seen that? Okay.
I've experimented with this before.
Gotcha. Okay. Honestly, if I plugged into my calculator right now, tangent of pi over 2, it probably would give me an answer, not undefined. Why? Try it. Tangent. Oh, that's the sign. Tangent pi over 2. I got an answer. You didn't get an answer? Why am I getting an answer and you're not? There is a reason. You're the right one. I'm the wrong one. Exactly. Mine's in degree mode. I'm very impressed that you all had yours. You must have all had yours in radian mode when you were doing it. All right. Whenever you hit sine, cosine, or tangent, you have to be mindful of the mode. Mine's in degree mode, so it's looking at that as the tangent of pi over 2 is like 1.57, so of 1.57 degrees. But you're getting an undefined value, which actually makes sense. Think about it. If pi over 2 on the unit circle, that's right here, right? The coordinate right there is 0, 1. What's the ratio for tangent? Give me letters. Y over x. Put 1 over 0. Can we have 1 over 0? No. So that is actually undefined. On a unit circle quiz, if you're asked for the tangent of 0, when you get something over 0, that's undefined. So make sure you put that circle with the line through it. Don't leave it as 1 over 0. So what's happening here is tangent can't equal pi over 2. Yes, it.
So do we want our thing to say 0.02?
No, yours should say undefined. If you got what I got, then you got to go back to your mode and change that to radians. You know what? That makes sense. When we graph the sine graph, we all change from radians. That's why you got one, right? Okay. So what is here is an imaginary line because x can't equal pi over 2. Anybody know what that line's called? We have that boundary there and the graph cannot equal that value. It's called an asymptote. What's the tangent of pi? Just plug in. What's the tangent of pi? Logan, what do you get? 0. How about tangent of 3 pi over 2? Undefined. So there's actually an asymptote there as well. In fact, there's an asymptote at every single pi over 2. Now the question is, all right, what happens in between? So right now you're in radians. Let's, if pi over 2, what's the degree measure of pi over 2? What's pi over 2 equal to? What's that? 90, yeah, 90 degrees. So let's see what happens as we get closer and closer to that 90 degrees, all right? Switch your calculators back to degree mode. And let's find some y values. Plug in the tangent of 45. What do you get? 1, okay? Plug in the tangent of 60 degrees. 1.7. Remember how the sine, cosine graphs actually went up to 1 and down -1? That's not the case here. Okay, that was 60 degrees. Let's go tangent of 80 degrees. So it just went from 1.7 to what? 5.6. It keeps getting higher, doesn't it? Try 89 degrees. 57. Very high. So actually what happens is all these values, they just keep going up. And they approach that asymptote, but they never touch that asymptote because x cannot be equal to pi over 2. Now let's go in the opposite direction. Try -45 degrees. Tangent of -45. -1. So what happens on the other side is it just kind of goes down like this. And that's the tangent graph. You have asymptotes at -pi over 2, pi over 2, 3 pi over 2, and so on. And then it crosses through halfway in between. And that's what that graph is looking like. If you wanted to graph it, switch it back to radian mode, and you can plug in the y equals the tangent of x, and you will see that graph. Okay? That's the tangent graph. And I tell you what, while we're here, let's add this. There are asymptotes, we're going to need those, at pi over 2, that's a 3, pi over 2, 3 pi over 2, and so on. That's where the asymptotes of that original tangent graph are. Okay? Let's try the cotangent graph. All right, so we do the same thing. Let's go with cotangent. Go ahead and mark it with pi over 2 and pi, 3 pi over 2, and 2 pi. All right. We go to the tangent graph here. All right, let's go with cotangent. So I'm going to go pi over 2, pi, 3 pi over 2. Keep in mind that the tangent or cotangent and tangent are reciprocals of each other. So how you could plug that into your calculator is you could take 1 divided by the tangent of whatever angle. For example, for the cotangent of 0, you would plug in 1 divided by the tangent of 0. What do you get? Plug that in calculator. Take the cotangent of 0. 1 divided by the tangent of 0. Luke, what's that give you? Take 1 divided by tangent of 0. Yeah, you get an error. So now the asymptotes are at 0, and guess where the next one's going to be? 1 pi. Yeah, pi. And at 3 pi, or I'm sorry, at 2 pi. So here we have asymptotes at 0 and pi, and so on. Now let's see what happens here. Take the cotangent, let's go 90 degrees. You have to switch back to degrees now. Switching back and forth. Make sure you're in degree mode. Let's find the cotangent of 90 degrees, which means you're typing in 1 divided by tangent 90. Actually, does that work? That may not work. That probably doesn't because you're telling it to do the tangent of 90 itself was undefined, so that's messing that up. Okay, let's see what's on either side of this thing. At 60 degrees. No, that's not it. At 125 degrees. Type in 1 divided by the tangent of 125. What do you get? What is it? Negative 0.7. So some negative number down here. Let's try the left of that. Try maybe 30 degrees. It's positive, isn't it? So with the big differences between the two is that the cotangent graph is decreasing in between the asymptotes, and the tangent graph is increasing between the asymptotes. The other difference is where their asymptotes are. So when you're graphing these, as I said, they're not nearly as detailed as the sine and cosine. I'll be looking for two things. Number one, did you put the asymptotes where they're supposed to be? And number two, do you have the right shape? The tangent graph is the one that's increasing. The cotangent graph is the one that's decreasing. All right, so let's work with an equation here. Let's try this. Y equals 5 times the tangent of 2 times the quantity of x minus pi over 4. Give me a second to jot that equation down. Okay. Now I'm going to restate what I just said. There are two things we're looking for. Where are the tangents and what's the general shape of this graph? If you relate this to the sine and cosine graphs, what does that pi over 4 represent? What did we call that? The PS, yes, phase shift.
Thank you.
Yes. It's the phase shift, which there would technically be a phase shift going on here. We don't necessarily have to look at it in that way. Here's what I'm going to do. I want to figure out where would the asymptotes be. Now, where are the asymptotes? They are where this graph is undefined. Okay? So, if we look at this, if that quantity ends up being equal to, look at your tangent graph, equal to one of the asymptotes of the original tangent graph. What are the asymptotes of the original tangent graph? Feel free to just look at the notes there. Pi over 2 and 3 pi over 2, right? So what I'm going to do is I want to find out when, for what value, would that quantity equal pi over 2? And for what value would that quantity equal 3 pi over 2? So what I'm doing is I'm setting what's the 5, honestly here, we are not going to care about that 5. All we care about is it a positive or is it negative? Okay? I'll focus on that later. So I'm going to solve these equations for x. Now you might look at that and say, well, let's distribute that 2. I would actually look at that and say, let's divide by 2. So that what that gives us is x minus pi over 4 over here on the left-hand side. And don't forget, if you're dividing by, if the fractions are involved, when you're dividing, you're actually multiplying by its reciprocal. So we're multiplying that by 1/2 to get pi over 4. Okay? I'm going to add that pi over 4 to both sides. If I add pi over 4, that gives me 2 pi over 4, which is pi over 2. It just so happened to be one of those original asymptotes. That doesn't mean what happened. So one of the asymptotes of my new graph is going to be at x equals pi over 2. All right? If we look at this other side, go ahead and take that second equation, solve that for x. Use the same steps that we just used over here. All right, so if we divide it by 2, which means you multiply by the reciprocal of 2, so you're multiplying by 1/2. When I got that, I got 3 pi over 4, and then add pi over 4 to get 4 pi over 4, which is pi. So here's what I have to do. Label those asymptotes, so you have pi over 2, there's an asymptote. At pi, there's an asymptote. Okay? I do want you to find that point that's in the middle. All right, so when you're labeling these, you do need to label the one that's in the middle. Now, it says in the middle, so that means it's the average of those two. What is directly between 1/2 and 1/2? What's that?
3/4.
3/4, yeah, good. So this will be at 3 pi over 4. Last thing to do is draw. Is the tangent graph the one that increases or the one that decreases? Increases. So all I gotta do is just draw the graph. Again, I don't care about the 5. That, the bigger that number is, that 5, the more it stretches it out. But the way that we're graphing these, I'm not real concerned about that. So we're just gonna go with the general shape of that. Okay? Questions there? See what I mean about saying these are a lot less involved than the others? Yes?
What about, do we ever solve it for like the negative pi over 2?
I would not. I would suggest doing this every time. Just because when you throw a negative, if you want to do that, you can.
But there's like never a situation where you should.
Nope. No, and then I'm sure we could probably find some scenarios where, hey, maybe that'll be a little bit easier, but I think you're fine going consistent here. And that's what else is nice about these. Sine and cosine, there's very little consistency with those. Here, you do the same thing every time. Okay? Now, if we have this graph, here's a cotangent graph. Yeah, sorry, Max.
Should we just neglect the amplitude?
Yeah.
Because it's,
Yep. And technically here, it's not even considered an amplitude. That's just with sine and cosine derivative ways there. But here, it would stress the graph out, but don't. I'm not worried about that. So the cotangent graphs, we're going to take a similar approach here. I'm going to set that quantity that we're taking the cotangent of. So I'm going to set this quantity 1/2 times the quantity of x plus pi over 2. I'm going to set that equal to the asymptotes of the cotangent graph. What are those asymptotes for the cotangent? 0. Yeah, that's how I remember. Co goes to O. And if there's 1 at 0, then there's also one where? Pi. They're always either both whole numbers or both fractions, something over 2. Tangent is over 2. So as we solve this, here if I divide by 1/2, that's the same as multiplying by 2. I'm just flipping that and multiplying. Either way, on the right-hand side, if I multiply that by 2, I get 0 still, so that makes it kind of nice. So I get x plus pi over 2 equals 0. And then subtract that pi over 2 from both sides, I get x equals negative pi over 2. Over here, I'm going to multiply both sides by 2 to get x plus pi over 2 equals 2 pi. And then I'm going to subtract that pi over 2. Need the same denominator. So that would be 4 pi over 2. So 4 minus 1 is 3. So I get x equals 3 pi over 2. Those are the asymptotes. So I've got one at negative pi over 2 and another one at 3 pi over 2. All right. Now, I want to find that value that's in the middle. What value is in the middle? What's between negative pi over 2 and 3 pi over 2? Now, if you ever struggle with that, really what I'm doing is I'm finding the average of those two numbers. Remember how to find the average? You add them up, you divide by 2. So what I could do is I could just take 3 pi over 2, add that to negative pi over 2, I get 2 pi over 2, which is pi, and then I take half of that number. So I'm taking a half of pi, so that's pi over 2. So the number that's in the middle is pi over 2. Again, sometimes it's obvious what that number is. Sometimes it's not. If it's not as obvious, then just average those two asymptotes. You're adding, in this case, I added negative pi over 2 to 3 pi over 2 and then take half of it. All right, now I need to look at this original graph for a second. Okay, so here we go. It's the cotangent graph. Is the cotangent graph the one that increases or the one that decreases? It decreases. However, be careful here. What's that negative do? Yeah, flips it. All right, if this were a positive 2, then yeah, that graph would be going down. But this takes the negative of that, which means just the opposite. It is going to go up. And negative in front of the whole function, that always flips. I remember the parabolas. If you have x squared, you have a parabola. If you have negative x squared, that's a parabola that moves down. Same idea. That's what a negative does. Any questions then? Okay. All right. Here is your assignment.